Okay, so two students are observing a book of mass 2 kilograms falling vertically from rest from a shelf that is 1.5 meters above the floor. And what we can see from scanning through the question is that student A is suggesting one model and student B is suggesting another, and we've got to analyze both of those models. So for part A, let's get ourselves a little diagram in terms of what's going on. So this is my book. We've got a distance to the floor of 1.5 meters, and we know that the book is falling in this direction. It's falling down towards the floor. So we know that we've got constant acceleration. So let's think about my equations of constant acceleration and work out what values I've got within the SUVAT. So in the downwards direction, I'm moving down 1.5 meters. I know that the book is starting from rest. I don't know the final velocity, but I do know that it's moving freely under gravity is the model that student A is suggesting. So I know that my acceleration is going to be 9.8. And what I want to find is the time taken. So it's the time that I'm trying to find here. So using our SUVAT equations, let's look at S equals UT plus a half AT squared. Got 1.5. My U is equal to 0 plus a half times A, so 4.9 T squared. That gives me T squared equal to 0.306, and so T equals 0.55 seconds. So that's under model A. That's what student A thinks is going on. So let's get for student B, let's read what's going on. Student B thinks that we've got an improved model where the book is modeled as a particle experience a constant resistance to motion of magnitude R newtons. So again, let's get a picture of what's going on. Here's my book. This is my ground. I've got 1.5 meters. I know that the weight of the book is 0.2 g. And I know I've got a constant resistance to the motion of R. That's the values that we've got there. So we've got this as our diagram now. So we need to find the acceleration because it's no longer moving freely under gravity because of the resistance. So if I apply Newton's law, F equals ma. I know that the book is still moving downwards, so I've still got my downwards direction of motion. So we're looking at 0.2 g minus my resistance is equal to the weight of the book, mass of the book, which is 0.2, times my acceleration. So let's have a look using our SUVAT at what information we have. S equals 1.5. We know that we're still starting from rest. We don't know the acceleration, so we're going to apply that in. We know that this time it takes the book 0.6 seconds to reach the floor. So we do have a time here, and it's the acceleration that we don't know. So we've got 4 variables here, and that's going to allow me to plug that acceleration back into here once I can find it, and that will allow me to find R. So again, S equals UT plus a half AT squared. My S is 1.5. 0 plus 0.18, because I know the time is 0.6, divided by 0.3, so I've got 0.18a. And that's going to give me A equal to 25/3. So if I plug that back into my equation, I've got R equal to 0.2 g minus 0.2a, so 0.2 times 25/3, and that gives me R equal to 0.29 newtons. And we're leaving our answer to 2 significant figures because we've worked including g within this question, so we want to make sure that we are not more accurate than the the values that we've used within the question.